All right, welcome. Today we're going to get right into it and talk about the stuff that makes up, well, everything. We're going to pull back the curtain on the secret dance of matter.
So let me ask you something. Just look around. The chair you're sitting on, the air you're breathing, you. What's it all made of, really? It sounds like a huge question, but the answer actually boils down to one simple idea.
And that idea is matter. Simply put, matter is anything that has mass and takes up space. But here's where it gets really cool. All of that stuff is made of these teeny tiny particles. We're talking ions, atoms, molecules, trillions and trillions of them. They're literally the Lego bricks of the universe. Okay, so these particles aren't just lazy. They don't just sit there. They're constantly arranging themselves in different patterns. And how they arrange themselves gives us the three main states of matter you see all the time. First up, let's talk about solids. This is the easy one, right? The desk in front of you, your phone, an ice cube in your drink, all solids. So what actually makes something a solid? Well, they've got a few key traits. They have a fixed shape, right? A rock is always rock-shaped. They're also super dense, and you basically can't squish them. And the reason for all this? It all comes down to their particles being locked in tight. Yeah, check this out. In a solid, those little particles are crammed together like sardines in a can. The forces holding them together are incredibly strong. So strong, in fact, that the particles can't really go anywhere. All they can do is just vibrate in place. Kind of like being in a super crowded concert where you can't move. You can only kind of jiggle. All right, on to the next one. Liquids. Water, juice, the coffee you might be drinking right now. Now, liquids, they're a little more free-spirited. They have a set amount, a definite volume, but they don't have their own shape. You know this, right? Pour water from a tall glass into a wide bowl, and it just takes on the new shape. It's happy to go with the flow. And they're usually a bit less dense than solids. So why do they do that? Well, it's all about those forces between the particles again. In a liquid, that sort of invisible glue holding them together, what scientists call intermolecular forces, is just weaker. The particles are still buddies, they're close, but they've got enough wiggle room to slide and glide past each other, and that's what lets them flow. And that brings us to state number 3, the one that's literally all around us, filling this room, but most of the time, you can't even see it. We're talking about gas.
Oh yeah, gases are the total free spirits of the particle world. They have no definite shape and no definite volume. You let a gas loose, and it's going to expand to fill whatever space it's in, whether it's a tiny box or a giant hall. Why? Because their particles are super far apart. This also means you can squish them together really easily, which is exactly what's happening in a can of compressed air. Just look at this. The forces between gas particles are practically zero. They just don't care about each other. They're buzzing with so much energy that they're just rocketing all over the place, bouncing off the walls, bouncing off each other. It's pure, beautiful chaos. Okay, so we've got solids, liquids, and gases. We see how their particles are set up. But what's the one big rule that explains all of this? What's the secret sauce? Well, it's time to talk about something called the kinetic theory of matter. Here's the mind-blowing part. Ready? Nothing is ever completely still. The kinetic theory of matter basically says that all these little particles that make up everything, they are always in motion. They all have kinetic energy, which is just a fancy way of saying the energy of movement. Even in that solid rock, the particles are vibrating. So what controls how much they move? One word, energy. Think of heat. When you add heat, you're just pumping energy into those particles. They soak it up, they get more kinetic energy, and they start moving faster and crazier. This right here is the key to understanding how matter changes. Because once you get that idea, that energy equals movement, you've unlocked the secret to how matter does its incredible shape-shifting trick. I mean, how it jumps from one state to another. Think about it this way. You've seen an ice cube melt, right? And you've definitely seen water boil in a pot. But what's really going on? What's happening down at that tiny particle level that we can't see?
Okay, this diagram here is basically our map. It shows all the different ways matter can change from one state to another. Let's walk through the main routes on this map.
It really just boils down to adding or taking away energy. You add heat to a solid, its particles start vibrating like crazy until they break free, and it melts into a liquid. Pump in even more heat, and those liquid particles start flying apart. and it boils into a gas. And it works the other way too. Cool a gas down, take away its energy, and it condenses back to a liquid. Cool it down even more, and it freezes solid. And then there's the super cool shortcut, sublimation. That's when a solid just says nope to the liquid phase and jumps straight to being a gas. Think dry ice?
Okay, but this brings up a super important question in science. When ice melts, are we actually making a new thing? Or is it just a change in appearance? This gets at the huge difference between a physical change and a chemical change.
This chart lays it out perfectly. Look at a physical change, like our melting ice. You don't get a new substance. It's still just water, H2O. And crucially, you can get the ice back just by freezing it again. It's reversible. Now, look at a chemical change, like burning a log. You end up with totally new stuff, like ash and smoke. And you can't exactly unburn the log, can you? It's a one-way street.
So here's the bottom line. All these changes of state we've been talking about, melting, freezing, boiling, all of it, they are physical changes. A water molecule is a water molecule is a water molecule. It doesn't matter if it's locked in an ice cube, flowing in a river, or floating around as steam. The molecule itself is the same. The only thing that's changed is how much energy it has and how it's hanging out with its neighbors. And that, right there, is the secret dance of matter. It's happening all around you all the time. When you boil a pot of water, you're witnessing trillions of particles get enough energy to break their bonds and fly free. When you see your breath on a cold winter morning, you're literally watching the water vapor from your lungs lose energy and condense back into a tiny cloud of liquid droplets. So now that you know the secret, what else do you see? What other everyday mysteries can you now explain?